output from this will be transferred to the secondary of the transformer, and this output is given to the base of the transistor 2. The working will be explained further in detail. Now, we have answered this why it is named so, why transformer coupled amplifier is named so, as the output of first stage is coupled to the second stage through a transformer, and the RC is replaced, that it is modified. RC coupled amplifier is modified, you have replaced RC by a transformer. Now, other components have the same role as discussed before in RC coupled amplifier, that is your resistances, capacitor C in and capacitor C e. Again we will have a revision for that. Capacitance C in, R1, R2 and Re, they provides the biasing and stabilization so that be varied. Ce provides the low reactance path, but we have changed the output. At the output you are having a transformer instead of your RC, and after the amplified output is achieved through this coupling transformer, it is coupled to the base of second transistor. Again the working is explained. When an input AC signal is applied at the base of first transistor of amplified AC, flows through collector circuit of transistor and hence through primary of transformer. Amplified output is transferred to secondary side of coupling transistor and is fed to the base of transistor of next stage. We have seen that this signal is further amplified and resultant output is obtained across the secondary terminals of the output transformer. Now, here we have no coupling capacitor in the circuit and DC isolation is provided by the transformer itself. Again the diagram, at the output we are having here amplified version, that is twice amplified. Transistor TR1 amplified at the signal first, again this amplified signal is the input to the transistor T2, it is amplified further and this output is given across your output transformer. Now, the impedance matching, we are discussing here that impedance matching is provided by the transformer. What is the impedance matching? It is the practice of designing the input impedance of an electrical load to maximize the power transfer or minimize the reflections from the load. That is, in simple part, it is P out is equal to P in, the maximum power output with respect to your input that is given to the circuit. Now, considering this the diagram, we have considered a transformer having a primary and a secondary. The resistance across the secondary, let it be RL, with the transformer turns ratio N1 by N2. But if we have to consider the resistance across considering the primary side, it will be changed, it will be different and it can be denoted by RL dash. Now, the ratio of these two resistances, that is RL dash by RL, can be denoted by this. As we all know, V is equal to I into R and R is equal to V by I. As these two resistances are from different point, one is from secondary and one is from primary. So, the voltage or current will also be differ, it will be V1 by I1, RL will be V2 by I2. Now, rewriting this V1 by V2 into I1 by I2, we know this can be replaced by a turns ratio N1 by N2 into N1 by N2. So, RL dash by RL is equal to your N1 by N2 square. Now, the example to understand it very clearly is if we want to match 16 ohm speaker load to an amplifier, so that effective load resistance is 10 kilo ohm. Just substituting this value to this formula, RL dash is equal to N1 by N2 square by RL. 10,000 is your 10 kilo ohm is your RL dash, it can be written as 10,000, 16 ohm is RL. Substituting the values, providing a simple mathematical calculation, your N1 by N2 square is equal to 625, N1 by N2 is equal to under root of 625, that is 25. So, the ratio of, that is turns ratio of your N1 by N2 provided by your transformer coupled is 25:1. That you have designed your transformer coupled amplifier for this turns ratio 25:1 by employing these two resistance value, that is 16 ohm and 10 kilo ohm. Now, the frequency response of transformer coupled amplifier is very poor because the gain is constant for only small part. Output voltage we know is equal to the product of collector current and the reactance of the primary. At low frequency your reactance falls, resulting in smaller gain, and at high frequency capacitance between turns winding act as bypass capacitor, which reduces your output voltage. That is, in case of your transformer coupled amplifier, you are having a very irregular amplification. Only for a small part of your frequency you are having a constant gain. Again, the advantage is higher gain is obtained using step-up transformer. No signal power lost due to the small primary winding. Also, this can be explained that you are not having any resistance component at the output of the first stage, that you have replaced RC by a transformer coupled, so there will be no voltage drop across the resistance. You are having the excellent impedance matching as you are using the transformer coupling, and maximum power at the output is achieved with respect to this impedance matching, that is P out is equal to P in. The disadvantages are, as you are using transformer coupled amplifier, it is larger in size. Again, for same reason it is bulky and costlier. It has the poor frequency response as the gain is constant for only small portion of your frequency, and this poor frequency response provides your irregular amplification. Also, it produces hum due to the nearby wiring. You are using a transformer coupling. Transformer coupling provided us with the noise that is known as hum due to the nearby wiring. Now, also the application for your transformer coupled amplifier, that as it is providing the impedance matching, the maximum power at the output, this transformer coupled amplifiers are used at the last stages of your multi-stage amplifiers, so that it can drive your load circuit efficiently. Now, the last coupled amplifier is your direct coupled amplifier. Here we have drawn a 3-stage direct coupled amplifier. Now, here it is seen that you are not having any coupling devices. No reactive components are used as resistances R, C or transformer. You have coupled stage 1 directly to stage 2. Again, stage 2 is coupled directly to stage 3. You have not provided any coupling devices in between these stages. Rest is circuit diagram is same, that you are having the input signal and the output is taken across the resistance RC. Now, why it is named so, we have considered it as your output of first stage is directly coupled to the input of next stage, and so on, without using any reactive components. Thus, no coupling device like capacitor or transformer is used, but the modification is that you are using the complementary transistors in case of your direct coupled amplifiers. Now, complementary means if at the first stage you are using a NPN transistor, at the second stage you will use a PNP transistor, and so on, and vice versa. If you have used a NPN transistor in first stage, in second stage you will use a PNP transistor, and vice versa. Now, operation, your direct coupled amplifiers are used for weak signals, that is less than 10 Hz, and this weak signal is applied to the base of the first transistor. The transistor will provide the amplification as transistor and amplifier action will be done. After transistor action, this amplified signal is obtained across resistance RC. Again, this amplified signal further fed to the base of next transistor, and so on, as you are having, it depends how many stages you have employed in your multi-stage amplifier. Now, these complementary transistors are used to make circuit stable with respect to your temperature changes. We all know that your temperature change or increase or decrease in temperature affects your current in your transistor as an amplifier. For increase in temperature, current increases by beta factor, but now it is opposite for the other transistor. As this increase in temperature is with respect to your NPN or PNP transistor, again you are using a vice versa or complementary transistor in the second stage, this increase of current or temperature will be vice versa for the second stage, that the increase of current by the factor beta will be a decrease of current by a factor beta in your second stage. Thus, this variation is compensated due to the complementary transistors. Thus, variations in one is tended to cancel in other, so that your stabilization is not affected, your Q point is not varied with respect to your change in temperature. The advantage is its simple circuit arrangement and there is minimum components used, and it is also inexpensive, low cost because no components are used, and it is used to amplify the low frequency signals, and it provides your uniform response up to high frequency. The lower cutoff frequency is 0 and your upper cutoff frequency is determined by the components used. Now disadvantages, it is not used for your high frequency signals, it is used only for your low frequency signals, that is less than your 10 Hz. Temperature may shift the operating point as temperature affects your circuit. Unwanted change in the output voltage without any change in the input, that is also due to the temperature variations. Also the transistor parameters change with temperature. So these transistor, direct coupled transistors are used, the application for this direct coupled amplifiers are for low frequency amplification. These are some amplifications for your direct coupled amplifier. It is used in TV receivers, computers, regulator circuits and other electronic instruments. It also forms a block for differential amplifiers and operational amplifiers. Now we have discussed in detail three types of amplifiers. One is your RC coupled amplifier, second is your direct coupled, and third is your transformer coupled. Now let us have the comparison in between these three types of amplifiers. This is the table showing the comparison or differences between the three types of multistage amplifiers: RC coupled multistage amplifier, transformer multistage amplifier and direct coupled multistage amplifier. The first difference depends upon the coupling, that how your first stage is coupled to the second stage. In RC coupled you are using RC coupling, that is a combination of capacitor and shunt resistance is employed. In transformer coupled multistage amplifier, the coupling is with respect to your transformer. And in your direct multistage amplifier, you are not employing any reactive components as resistance, capacitances and transformer. The first stage is directly coupled to your second stage. Second particular is space. For RC coupled amplifier, the space occupied is less as the components used are simply resistances and capacitances. For transformer coupled, as transformer is employed, it makes the circuit bulky, so more space is required. In direct multistage amplifier, least space is required as no components are used. The cost for RC coupled amplifier is low, for transformer coupled it is more, and for direct coupled it is least. Impedance matching, that is maximum output power with respect to your input, is not provided by your RC coupled because due to the loading effect. For transformer coupled, due to the turns ratio, you have the excellent impedance matching. For direct coupled, you have the least impedance matching. Frequency response of RC coupled amplifier is excellent in audio frequency range. For transformer coupled, the frequency response is poor because your gain is constant only for a small part, and frequency components are not equally decoded. Frequency response is best for direct coupled, but that is also with respect to your low frequency. Transistors used for RC coupled and direct transformer coupled are same, that is NPN and NPN or PNP or PNP, but in direct multistage amplifier you are using the complementary transistors, that if you are using in first stage NPN, the second stage will be vice versa, that will be PNP. The noise is less in your RC coupled amplifier. In transformer coupled, the noise is more, that is a hum is produced in case of your transformer coupled amplifier. In direct coupled it is less. The loading effect in case of your RC coupled amplifier is more, as we have discussed that your resistances are in shunt in the next stage. Transformer it is less, and in case of direct multistage amplifier it is minimum. The applications we have also discussed. In RC coupled amplifier, it is used as a voltage amplifier and it is used in initial stages of your multistage amplifiers. Transformer multistage amplifier is used as a power amplifier as it provides maximum output with respect to your input, so it is used as the last stage of your multistage amplifier. Direct multistage amplifier, it is used for only low frequency amplification, that is low frequency amplifier can be used by direct multistage amplifier. This is all we have discussed about the multistage amplifier, that is what was the need, what is the basic definition of multistage amplifier, different definitions regarding multistage amplifier, and with respect to the coupling of multistage amplifiers, how one stage is coupled to your next stage, you are having the different types of coupling. Regarding this type of coupling, you are having different types of amplifiers as RC coupled amplifier, your transformer coupled amplifier and your direct coupled amplifier. It depends how your first stage is coupled to your next stage.